Okay, last time, we were in the middle of talking about testing and just in general test design, why are we testing things, what kind of different kinds of tests exist? And how should we be thinking about writing our tests? One of the exercises that we had here was thinking about different paths through if statements. So we had 3 if-else statements, there were 8 possible paths through that. And if we had 20 if-else statements, then there were over 1 million possible paths through that. And trying to write a unit test for every possible path works if you have 3 if statements, and really does not work if you have 20 if statements. So we need to employ a more intelligent design to how long do we have to write tests. What can we be targeting in those tests that maximize the chance that we're looking at the critical functionality of this software, or things that when they break are going to be catastrophic, or the most likely things to do. You want to write tests that target most likely and critical functionality more so than really specific edge cases. But maybe even the really specific edge cases are important, because if for some reason that causes your program to crash in a way that can't be recovered and saved, that's going to cause something that can be very frustrating to an end user if they can't save their work and their work gets lost because they tried to do something that seemed reasonable or feasible and there just wasn't a unit test written for it. So you didn't know that crashed your program in that way. So designing tests is as important as designing code. We want to try to find the most errors or the most important errors within the time that we have to write the tests and the number of human hours, not saying man hours, but human hours we have for finding bugs, because we have a limited amount of time for that. So we should have some approach so that we don't all write the same tests, that we don't write a bunch of overlapping tests, that if one of them is gonna fail, then all of them fail. That's not particularly useful, we spent the time writing all of those extra tests, because they don't test anything new or different. So what do those approaches look like? So test scenarios. First of all, if you're part of a company, it's going to be a business requirement that your software has a particular level of testing. Note that as you write these scenarios, you can test directly off of scenarios. They don't have to be tasks, but the scenarios kind of write the test for you. So you can map scenarios directly to tests. Given that tells you how to set up the test, what needs to be done to create a situation. This tells you the actual functionality that you're testing within the test. Here are the lines of code that I am executing as I attempt to get from the given to the then in a scenario. And the then becomes the acceptance criteria of the test. Then I see something else. I'm on this page. This tells you whether what needs to be true for the test to succeed or what is going to be false if the test is going to fail. So scenarios map very nicely to testing, which is really why we have those scenarios there in the first place. They help us to make tasks, yes. They're a middle ground between user stories and tasks, yes. But they're great for writing tests. As an example, you may want to do things like check the login functionality. Check that an order can be created. If you have an order, then an order can be opened. A user with really strange grammar can fax an order. Check that the information displayed in the help menu is actually correct. Lots of possible test cases that you can make for any of these designs. So you have a general test design, how many tests do you write for the functionality that you want to check? So we want to check the login functionality. Then we can look at the response from our application when we enter a valid name and password. What response do we get when we enter an invalid name and password? What happens when it's empty and we try to press the login button? What happens when you enter SQL injection into your username and password? So all sorts of different kinds of tests that test for different things can map to the same functionality. Note that the scenarios that you write are going to be vague, and there will be many tests that you can write from a particular scenario. So there is certainly some thinking that you'll need to do, some brainstorming about what are all of the ways that I can test this particular functionality to make sure that it does what it's supposed to do. The scenario is not the be all and end all, it's meant to be the documentation that starts that brainstorming path. So we write a test. We want to enter a valid name and password. So to do this, given that we have a valid name and password, when we press login, then that login is successful and we see that person's homepage, that person, whatever the application should land on after a successful login. So that's the scenario that would have been created. So we need to make sure that we document that. We have a test for that somewhere. So we know if it fails, what test it's referring to. Stuff like that. Questions so far? Comments? If you're going to document a test, this is the usual kind of information that's useful. You want to give an identification number to your test. It says, here's a test case. So here's the information that we're entering as that test case. You can break down these test cases into categories so that you can lump like tests together that test certain functionality. That way you have an easy way of, if you need to refer to particular tests, you can open up the associated test file that has those tests in. A description of the test, because we know that if a test fails, it's nice if you can just read the test error script and know exactly what happened and what the test did. But if you don't know that, or you can't glean that from the error message of the test failing, you want to be able to go to the documentation that will have a good English description of what the test is testing. And then, of course, the system version that was used. When was this test written? For which version of your code? What system was this run on to create this when you created the test, when you tested your test to make sure that it's doing what you expected? So versioning information is useful there. We're going to transition a little bit from here. Any questions before we move on to white box versus black box testing? Anyone heard those terms before? White box and black box testing? A little bit? Couple people? So white box testing, you can think of this as like looking into the box, and since it is transparent or translucent, you can see some of what's inside. This refers to the actual code that you're running the test on. If you test and have access to the code, then we can construct cases based off of the knowledge of how it is implemented. The purpose of white box testing is we want to find the programmatic errors, not just be able to document the program doesn't do, the application doesn't do what I expect it to. It means that there's an error in the functionality, and now we can actually go look at the functionality to try to determine how that is. So do note that that's not necessarily driven by requirements, but we need to know what the requirements are in order to be able to do it. This is mostly unit tests. So unit tests are all white box tests because unit tests execute the code. You're not just interfacing with the application's inputs and outputs. That's more black box style, where it doesn't really matter if you don't have access to the source. An end user can still test something, discover a bug, and send a bug report, even though they don't have access to the code. But if you do have access to the code, if you are a developer, then you can do all sorts of white box styles of tests. Questions on the idea of white box testing before we dive into the different testing phases? different kinds of tests you can write. So now we're going back over that list that we talked about yesterday: unit tests, integration tests, system tests, etc. So here's unit testing. It is the lowest level of white box testing. You're going to be doing this on small pieces of code, as small as you can possibly test. So over an object, the object's functionality. Over methods within an object to test when I execute this code. Does it do what does the object behave in a way that I expect it to? Anything that is procedural, that doesn't necessarily require an object, but is a function that does some computation. Does that work given particular inputs? Do the outputs match what you expect? So these are written by the programmer, the person who's actually writing the code, or someone who is responsible for production level testing. In very large companies, these roles are often split. You have developers and you have testers. But in smaller companies, you will find that developers are responsible for doing both. So a tester can help with this, but you need to understand how the program works on a line-by-line basis. And that's very hard to do from an outside perspective. So the person who's actually writing and implementing it and is able to justify the design decisions behind their code, that's the person who should be writing these tests. Each unit test should be able to be run independently. You don't want tests that are reliant on each other. So each should be run independently. Each unit is tested in isolation, meaning that you don't want to write a test that tests when I do this, and this, and this, and this, that calls this and does that, then this returns that to here, and this returns that to here, and this returns that to the very beginning, and this works. Because if that test failed, there are multiple failure points in that test. You want to make sure that there's only a single failure point that you are testing in your unit test wherever possible. You don't want to have to interpret what happened in that unit test. The fact that the test failed should interpret it for you. There's a bug in this small piece of code that shows its head when this input is given to it in this condition. So again, make that as small as possible. Types of unit tests. Interfacing with other units is good for that. If there's communication between this unit and that unit, test just that communication. If I send something to this, do I get a response? Local data structures. If I add something to this list, does the size increment? Something like that. Independent paths to the code. We talked about there being different if-else paths. If there are 3 if-else paths, then maybe you write 8 unit tests where we test each possible path through that to make sure each one of those paths does what's expected for a particular input. Error handling paths. How does your program crash if you give it invalid input? So should it crash? How should it crash? Does the error message, does that match what you would expect it to? Boundary conditions. This means if your program behaves one way, if the user inputs 5 or less, and another way, if they input 6 or more, a boundary condition would be test 5 and test 6. Maybe you also want to test negative 10,000 and 10,000, but test right on that boundary to make sure that as close as you can get to that boundary from either side still has the behavior you would expect. Questions on unit tests in general? I'm hoping that most of you have seen that in enough detail in past classes that you really know what they are and have seen that at a deeper level, but if that's not the case, I'd be happy to go through it in more detail than this. Come see me in office hours. Unit tests are incredibly important to developing. Next one we're going to cover is the integration test. So this is what happens when we get different units together to determine, do they function correctly Not just do I get a response from this unit, but is that response correct? If I have to do work, then pass that work to another unit. That unit does some work, and then it returns an answer to me. Did that system, that subsystem work correctly together? Note that if this unit weren't doing what it's supposed to be doing correctly, that's a unit test that should fail. If this unit weren't doing this part of this correctly, then that should fail. But as we've seen in this project, if there's a communication breakdown between the two developers who wrote these two different units, maybe the unit tests both pass. But an integration test will fail because of the assumptions that the developer made as they created these components. Maybe those are different tests testing different things, so that when you put them together, they don't do what they're supposed to together. So the integration test tests that functionality. So we're moving up in the scale. This is not just a small functionality test. This is testing the interfaces between these pieces. Does a whole subsystem work together as you expect? So focus on the interfaces between those modules, communication between the units that have separate unit tests written for them. You want to think about what those integration tests are going to look like as you define what your system is going to look like. So in our very first lab, after Sprint 1 started, we're drawing a bunch of class diagrams on the board, relationships between them for the classes. How are these components all going to work together? This is when you think about this method requires something from this class. We should write an integration test for this that shows that when this method calls this class and gets back this response from this other unit that two different programmers are going to write, this is where that test should be happening. We need an additional test for these two units working together to make sure that they work in harmony. We will continue this on Monday. We may actually take an aside from testing because Sprint 2 will officially be started on Monday. And there will be a technical requirement that I will go over that will require that I cover some content that I haven't, and I want you to begin working on Sprint 2 immediately because we'll want all of that time before. So we may take an aside from this, but we will come back. If you have not brought up your quiz, please do so before I leave. All right.